So, last class we have discussed the statement of the what is called minimum time control problem of a linear time invariant system. Let us recap this statement of the problem, and then we explain the solution of minimum time optimum control problem with an example. So, let us call the linear dynamic system is given by x dot is equal to a x plus b u. U is the control input and x of t 0 at time t 0 initial time t 0 is x of 0 is given. So, our problem is to drive the state from initial time t is equal to 0, the state value is x 0, drive this state to a final state at t is equal to t f, where x f is given in a minimum time. So, that is our problem. So, first we have to check whether the system is completely controllable or not by the what is called this rank condition. We have to satisfy b a b a square b a n minus 1 b n is the number of states involved in the system dynamic equation. That rank must be n, then all the states will be controllable. And not only this, we have a constraint on the input. Most of the physical system having a definite input to the systems, agree. So, that constraints are given maximum value of input to the plant u max and minimum value of the plant is u min, agree. Generally, this upper and lower limit are same with the positive sign and negative sign, this one. So, our problem statement is like this way. It is desired to apply an optimum control input u star that satisfy the constraint, and now in case of this alpha 1 we have constrained the 1 unit of input. For all the inputs I is equal to 1 to m, m is the number of inputs, drives the state of the system initial state x 0 to the desired final state x f, agree, in a minimum time. So, our performance index is this performance index we have to minimize, that means we have to find out the minimum value of the time t f for that one, and that is been solved by using what is called Pontryagin principle, minimum principle PMP. And when the when our terminal state or the final state is 0 at the origin, we want to drive the initial state to the origin, then the problem is called optimal time optimal regulator problems. So, this is our problem statement was that, and we have shown it last class and derived it how to approach this one by using the Pontryagin minimum principle. Let us take our one example. So, that we drive the state from initial state x t 0 u which is equal to x of 0 to the final state x t f is equal to 0 in a minimum time t f by using what is called switching the control law in two state, either plus 1 or minus 1. So, that is called bang bang control, bang bang control. So, what is bang bang control? A control signal which always take its maximum, always takes its maximum or minimum value with finitely many switching between them, minimum and maximum value between them is called a bang control. So, the two maximum minimum state is there for controlling, either you switch on +1 or you switch on -1, and the state will drive from initial, this control action will drive the state from initial state x t is equal to 0 to the final state x t f is equal to 0 when at the origin in minimum time t f. For any initial condition x 0 to a final state x t f is equal to 0 will drive the initial state to 0 by proper sequence of control actions. That means, either you switch on to +1 or -1 in this way, and many times you have to do depending upon the order of the systems. So, let us take in one example and illustrate the problem, the minimum time optimal control problems. So, given the dynamic system is given the system whose dynamics are expressed in this form, that x 1 dot of t, there are two states, let us call, we consider the second order system which is expressed in time domain, and in general we write x dot of t which has a two states are there, dimension of this equal to, it is given at 0 1 0 0, and there is a x 1 of t, x 2 of t, and that is 0 1 of u of t. So, our equation is, this is A matrix, this is a state vector, this is the B matrix. If it is single input, we write generally small b, and this is the u of t, and if it is a multi input, capital B and capital U, this. So, this is our dynamic equation with the performing index, j is equal to t 0 to t f, t 0 is equal to 0, and d t, which is nothing but a t f. Therefore, that means we have to minimize that performing index with the performing index, minimize the performing index with minimize the performing index. This is the performing, this performing index is minimized, not only minimized, with the constant control input constant mod of this is equal to less than equal to 1. Agree? And this constant means that our control input is +1 to -1. This constraint means that the control input must be control input magnitude must be within 1 or not greater than 1, must be within 1 or not greater than 1. This is 1 means this, that is our problem. So, so how to solve this problem? So, our basic problem is, to transfer the state x of t 0 means initial state, transfer the initial, you can write it initial state x of 0 to x of 0 is this to the final state x of T f is equal to 0 means origin in minimum time. When T f must be minimum. So, if you recall, it just state given the system, our problem is to transfer the state initial state to the final state T x T f to 0 means origin in a minimum time by minimizing this performing index. Not only that, subject to constraint, control input constraint, that magnitude of u cannot be greater than 1 or within 1. So, that is problem. So, the solution of the problem, if you follow the what we have discussed last class, first you form a Hamiltonian matrix, that our performance index, if you see that integrand part is 1, coefficient of this is 1. So, 1 plus lambda transpose of t into a of x t plus b u of t, that is our this. And let us write, since we have a number of states is 2. So, the dimension of lambda is also 2 row 1 column. So, it is a transpose. So, if I write the each element of lambda, lambda 1 of t partition lambda 2 of t, write corresponding matrix A, B in this expression. So, our A matrix is, if you see, our matrix is 0 1 0 0 multiplied by x, x means x 1 of t and x 2 of t. So, multiplied by b, b is 0 1 then u of t. So, now you simplify this one. If you simplify this one, you will get it 1 plus lambda 1 of t, lambda 2 of t, then this into this, this into this. So, it will be a x 2 of this and this into this into this 0 plus u of t. So, that which is nothing but a further expanding this one lambda 1 of t x 2 of t plus lambda 2 of t u of t. Let us call this equation is 1. Now, see the Hamiltonian matrix, that is a linear function in u, and not only that, you can, if you use the what is called Pointosian minimum principle, then this function will be minimum when this value of this one is minimum. So, that only possible by selecting the value of u of t with the knowledge of lambda of t. So, the co-state vector, the co-state equation or vector are, so co-state equation are, what is the co-state? Lambda dot is equal to lambda dot of t is equal to minus del h del x of t. That is our basic equation that we have seen from calculus of variation, how to optimize the dynamic systems. This is the things. So, this x is a dimension of 2. So, lambda also dimension of 2. So, this we can write it further, we can write it minus c h function. I have to differentiate with respect to x. So, there is no x term involved in the expression 1. So, that will be a 0. Then differentiate this gradient of this with respect to x 2. So, this is the only term is there. So, it is lambda 1. So, lambda 1 of t. So, the co-state vector expression is this one, and we can write it because it has a two components, and that two components is lambda 1 dot is equal to 0, another is lambda 2 dot is equal to minus lambda 1 of t. So, let us call this equation is 2 and this equation is 3. So, we can easily solve the equation 2 and 3. In general, even if you get the what is called the matrix is not a special structure, in all elements are there, we know how to solve the what is called state equation. Here also we will come this type of equation, and we know how to this x dot is equal to something like A x form, you will get it, you can solve. So, looking from this one, I can write it first. See, from equation 2, from 2, what you can write it? Integrate that one with respect to, that is delta 1 is nothing but a delta 1 dot is in a lambda 1 dot is nothing but a this thing. So, this equal to 0. So, now this implies that lambda 1 of t is equal to lambda 1 of 0. Let us call this equation is equal to equation number 4. So, you take this that side, then integrate from 0 to t. So, say that will come lambda 1 of t minus lambda 1 of 0, and right hand side is 0. So, this is the expression, and use this expression in equation 3. From equation 3, lambda 2 dot of t is equal to minus lambda 1 of t, which is equal to minus lambda 1 of 0. Lambda 1 of 0 is replacing this is that one. So, what is the solution of that one? The solution of that one, I can get it lambda 2 of t, or you write it this lambda t of t del d of t is equal to minus lambda 1 of 0 this. So, now take dt this is, and then integrate from 0 to t. So, this shows that lambda 2 of t is equal to minus lambda 1 of 0 into t, and lower limit t is 0. So, this term will not be there, then another term is there lambda 2 of 0. So, this is our solution of that lambda 2 expression. So, this expression, let us call this is equation number 5. Agree? So, from 4 and 5, I can now say from equation 1 means Hamiltonian equation H of from equation 1, this equal to 1 plus lambda 1 of t into x of t plus lambda 2 of t into u of t. So, using Pontryagin minimum principle, I can say that when lambda 2 is positive, u 2 is negative, we will consider, then this function value will be minimum. Then when lambda 2 is negative, u 2 value is positive. So, what we write in the optimal value of this u star of t is equal to 1 if lambda 2 of t is less than 0, and that is equal to minus 1 if lambda 2 of t is greater than 1. So, it is just switching depending upon the value of lambda 2 of t, and lambda 2 of t expression is this. But unfortunate part of this one, we do not know what is lambda 1 of 0 and lambda 2 of 0. So, these two equation we can write in mathematical form by using the signum functions, sine function, sine function u star of t is equal to minus sine of lambda 2 of t. Agree? Sine lambda of 2. You know the expression for lambda 2 or sine, that lambda 2 expression is that one, lambda 1, lambda 2 of 0 minus lambda 1 of 0 into t. So, that I am writing lambda 2 0 minus lambda 1 0 into t. So, this. So, what is the sine function? I just explain this. Sine of z mean g sine SIGN sine of z is equal to, it is 1 if z is greater than 1 or greater than 0, if it is minus 1 if z is less than 0. So, the sine function sine of z value will be 1 if z is greater than 1, value will be minus 1 if it is less than 0, means negative. So, it is switching only, u is switching to plus 1 or minus 1. So, this quantity when it is positive, then u I am switching to a minus 1, when this quantity is negative, then negative 1 plus I am switching to plus 1. So, our control action is switching control law, either I am switching to plus 1 volt or minus 1 volt or 1 unit minus 1 unit. So, it is something like sine function is that one, if you see. So, let us call this is lambda 2 of 0, this is 1 u of t, this is minus 1, this is 0. So, now look at this expression, when this is positive, u is negative, then we are applying the voltage to the, we are applying the input to the system is minus 1, and correspondingly system dynamics will change. When this is negative, sine of this negative quantity is the negative positive, then we are applying positive control signal voltage or signal. Agree? So, again the system dynamics will change it. So, now see one by one what we are doing. Now, if u star of t is equal to 1, u star t is 1 when this quantity is negative, then sine of negative quantity is minus sine, that by definition of. So, if it is 1, let us see our corresponding dynamic equation of the system. X 1 dot is equal to x 2 of t. Agree? Then x 2 then x 2 dot of t is equal to 1, because x 2 dot is equal to u is equal to 1. So, now what is the solution of this one? The solution of x 2 of t is equal to minus, this is dt t plus x 2 of 0. So, this is our solution of x 2. So, if you put in this expression, the x 1 of dot of t is equal to x 2, which you can write it x 2 0 plus t. So, now what is the solution of that one? Solution of this one x 1 of t is equal to that x 2 of 0 into t. Agree? because its lower limit is 0 and upper limit is t. So, it will be coming t. So, this one is t square by 2, upper limit is t and lower limit, that lower limit term will not come from this integration part. So, plus x 1 of 0. So, this is our solution of that one, that x 1 you can write it x 1 of 0 plus x 2 of 0 into t plus t square by 2. So, that now this I can write it into a, say what is x 1 of 0, I am writing this plus x 2 of 0, the initial condition of the state, and t, what we can write it from this expression, you see t is what, x t of t minus x 2 of 0 is equal to t is equal to this. So, put the value of t here, that x t of t minus x 2 of 0, this is that one. Put the value of this, that is x 2 of t minus x 2 of 0 whole square divided by 2. Now, if you simplify that one, because just you simplify this one, then this equation ultimately you see this is x 2 square, x 2 a minus b whole square, x 2 square by 2. So, it will come x 2 square by 2 and plus x 2 square by 2, and here we will x 2 square only. So, it will be a minus x 2 square by 2, then twice x 2 x 0, x 2 x 0. So, that is 1 x 2 x 0 here. So, that will be plus x 2 x 0. So, let us write it, that next is this term is there x 1 of 0, I can write it. Now, see this one. So, that will be a this into this. So, minus this into this, the minus x 2 square, but here is half. So, minus is coming, then x 2 0 into x 2 t, here is twice x 2 0 into x t divided by 2. So, 1. So, that will be cancelled out. So, ultimately we will get it this expression after simplifying this one. So, x 2 square by 2 minus x 2 square by 0 and x 1 of 0 for u is equal to plus 1 positive. This, let us call this equation, what is the equation we have come across, up to 5, last equation is up to 5, this equation we have up to 5. So, let us call this equation is 6, this is equation number 6. Similarly, we will see when we will apply, you see the dynamics of the closed loop the solution or response of the system is this, when you put the value of input is minus, because control action is applied different, minus 1, then what is the solution or the trajectory of x 1 and x 2, you see. For u star of t is equal to negative, the state equation is x 1 of t is equal to x 2 of t, that equation R. This is one, another is x 2 dot of t is equal to u and u is minus 1. Similarly, I can find out what is the value of x 2 of t by solving simple integrating both sides and taking the limit t is equal to 0 to t is equal to t. So, this equal to your will be x 2 0 agree minus x 2 0 minus t. So, this is the solution of this one. Then what is this? x 1 t dot is equal to x 2 t, and what is x 2 t is nothing but x of 0 minus t. Now, you integrate this both side, and with a lower and upper limit t is equal to 0 to t is equal to t. Then you will get x 1 of t is equal to that x 1 of 0, then it will come plus x 2 of 0 into t, then t square by 2. Now, let us call this equation is okay, we will not. Now, put the value of t. What is t expression? T is equal to, you can write it x 2 0 minus x 2 of t. That is our expression for t, x 2 0 minus x 2 of t. So, put this value here, x 1 of 0 plus x 2 of 0, and the value of t is just now here x 2 of 0 minus x 2 of t. Agree? So, minus t square and x 2 of 0 minus x 2 of t whole square by 2. So, after simplification this one, as we have discussed earlier, that case you will get it, this value will get it, that x 1 of t, that is x 1 of t, you will get minus x 2 square of t by 2 plus x 1 of 0 plus x 2 square of 2, x 2 square of 2 by 2. See the difference for u is equal to minus 1. See the difference this. If I write it in the same manner of that one, x 1 x 2 square, this expression you can say is nothing but a, this one if I rewrite this one, x 2 square of this by 2, then this is a plus, and I can rewrite it is a minus plus x 1 of 0 minus x 2 square of 0 by 2. Okay. Just if you see this one, so this, let us call this is equation number 6, this is equation number 6, instead of this one this is 6. Now, look this expression and this expression, this is equation number 7. So, when the control input u is applied, the solution of or trajectory of x 1 and x 2 is how they differ. This is x 2 square by 2. So, here is minus x 2 square by 2. Then this constant term which depends on the initial condition of the state, this x 1 0 plus x 2 square of 2. Agree? So, these are the two equations. Now, easily we can plot the trajectory of what is called equation 7 and 8, 6 and 7, we can plot it in phase plane. There are two states are there, and we can plot it this, and basically this equation 6 and 7, if you look, equation 6 and 7 is a parabola equation. Okay, both represent parabola equation. Depending upon the initial condition, the parabola will be different, but nature of this in phase plane is a parabola. So, let us see if we plot it this, what is the nature of this curve, we will get it. So, from equation 6 and 7, from equation 6 and 7, we have one, you see, x 2 square of t divided by 2, 6. Let us call this one, I am writing this, x 2 square of this is equal to this equal to x 1 of t minus C 1. agree, where C1 is equal to say here this I am keeping it is from equation this series, this I am taking it, this whole thing I am considering as a C. So, C1 is equal to x1 0 minus x2 square 0 by 2. So, that is from equation 6 I am writing. Similarly, from equation 7 I can write x2 square of t by 2 is equal to minus x1 plus C2, and where C2 is equal to say equation 7. This equation 7, if I take this is that side, x square by t, s square t of 2 is equal to minus x 1. So, and plus this is you write it C 2 and this is you write it C 1, this is C 1. Okay. So, this where C 2 is equal to x 1 of 0 minus plus x 2 square of 0 by 2. So, this is the two parabola equation, the y square is equal to 4 a x plus some constant term. When constant term is there, that vertex is shifted to the right or left of this one of the parabola. So, let us see if you plot this one, and this is for this expression for u is equal to plus 1 and this is u is equal to minus 1. This corresponding u is equal to minus 1 and this equation corresponds to is equal to plus 1, this equation. Okay. So, let us plot it in phase plane. So, there are two states are there. So, x 1 and x 2 I am showing here x 2 and this is 0. Let us call C 1 is equal to 0, that C 1 is 0. Then what is this one? This is the equation of parabola. When x 1 is 0, x 2 is also 0. So, it is when x 1 is some positive quantity, then x 2 is plus minus. So, this nature of the curve is like this way. Okay, and this is correspond to C 1 is equal to 0. Now, tell me when C 1 is greater than 0, when C is greater than 0, what will be the its nature of this curve? When C 2 C 1 is greater than 0, what will be this value? So, this value now C 1 is greater than 0, if it is there, this curve will be like this way. So, I am just writing in this side C 1 is greater than 0, but all these cases u is C 1 greater u is plus 1 and all these cases are u is, I can write it u is plus 1. Here also u is plus 1, u is equal to plus 1, this C. Now, C 1 is less than 0, less than 0 means if you put it that side, less than 0 is some value of x, that this will be looks like this way. So, in this side C 1 is equal to less than 0 and this is C 1 is 0 is this one. So, this is corresponding to this all these things corresponding to u is equal to plus 1. Now, let us see for this one when u is control input is applied u is equal to minus 1, what is this, you will get it. So, again consider C 2 is 0. If C 2 is 0, if C2 is 0, then this is, you see, y is equal to minus 4 a x. Okay. When x is equal to x 1 is equal to C2 is 0, when x 1 is equal to, let us call 0, x 2 is 0. So, it will start from this one. When x 1 is minus, okay, minus minus plus, the x 2 is plus minus. So, this will be a curve is like this way. So, this is C2 is equal to 0. Agree? When C2 is positive, when C2 is positive, tell me which side I have to draw it, that one. C2 is positive, but x1 is negative. C2 is positive, x1 is negative. Okay? So, this will be a, because at same value of x, the x2 value will be more. So, C2 is positive, then our curve will be like this way. So, this side C2 is positive, and now C2 is negative, C2 is negative, agree? C2 is negative and x2 also negative. So, that value will be below the C2 curve. So, this is C2 less than 0, and all this curve u is equal to minus 1. This curve is u is equal to minus 1. Okay. Now, see our initial condition. Now, question is coming, look at this expression. Our initial condition can be anywhere in the 4 quadrant. Let us call our initial condition is here. I am just showing you our initial condition is here. X 0 is here. Then what is the dynamic equation is there? X 2 dot is equal to x 1 and x 1 dot is equal to x 2. X 1 dot is equal to x 2 and x 2 dot is equal to u, and u value is your maybe plus 1 or minus 1. Okay. So, u 1 is equal to either plus 1 or minus 1. Let us call this is that one. So, it can, this point can lie either this green curves parabola or red parabolas, anywhere you can write it. So, let us call it is here. So, what is the value of x 2? Positive. X 2 value is, see here, x 2 value is positive. If x 2 value is positive, then x 1 dot is positive. Then which direction, the velocity is positive, then which direction x 1 will move? X 1 will increase, because its derivative is positive, x 1 is increased, that means it will go like this way. As I told you, it can be in the red colored parabola or green colored parabola. So, if it is a red colored parabola it lies, then it should increase, agree. So, it is going away from the origin, but if it is in the what is called that green parabola, so x dot x 1 dot is positive. So, x should increase. So, the curve x is increasing along this curve, see this one. So, if it is a, so x 1 increasing, it is going like this way. So, it is approaching to, because x 1 is increasing, agree. But if it is in this curve, let us call it is a red curve. So, x 1 is increasing. So, it will move like this way, it will move like this way, agree. So, it is going away from the origin. Suppose it is on the green parabola. So, x 1 should increase. So, it is going in this way, agree, and it is approaching to the origin. So, if it is the approach, if it is like this way, let us call it is coming here. So, still x 2 is positive, sorry, x 2 is positive, the x 1 should increase. When it comes here, x 2 is negative. X 2 is negative means what? X 1 is negative. That means x 1 should decrease, and see it is decreasing. It is decreasing and decreasing, in this way it is decreasing. So, when it hits here, agree, then what is this one? This is the trajectory for when u is equal to 1, and this is here, it is going along the green trajectory, dotted green trajectory, and u is equal to 1. When it hits here, that u is still 1, u is still 1, but it hits that switching surface, this one, c is equal to 0. When it is 0, still this u value is 1, agree. This u value is 1, and this u value is what? Minus this. When you are coming here, the u is equal to minus 1, but when it hits here, u is equal to plus 1. So, it switch here, agree, and you see x 2 is negative, that x 1 is decreasing, and it is ultimately it will come to origin here. So, if you see this one, our switching surface is at this point, if you see x 2 is the initial condition, at this point that x 2, once again I am telling you, let us call our initial condition is this one, x of 0, and x of 0 means x 2 is positive. When x 2 is positive, see x 2 is positive, x 1 should increase. So, it may fall in this parabola, or it may, this point may lie on this parabola. I am telling you, suppose it is lying on this parabola, agree. So, x 1 should increase. So, it will go this way, it is going away from the origin, because we have to drive the state to the towards the origin. And now, if it is on the green parabola, that means equation number 7, agree, u is minus 1, and this trajectory is u is equal to minus. So, it will drive this one in this direction, because u x is x 1 dot is positive, since x 2 is positive. So, it is going, and x 1 is increasing in this way. When it is at this point, x 2 value is negative. Negative means x 1 value should decrease. You see, it is decreasing this one value from here to here, x 1 is decreasing. When it hits here, u value is changed. Previously, u was minus 1. Now, you see this, it hits here, u is equal to your 1. It hits here also, you see, it hits here also, no doubt, but if it is it cannot go, it cannot reach to the origin, it is going like this way. So, if it hits here, then along this path, u is equal to minus 1, along this path x 2 is always negative, means x 1 is decreasing and approaching to 0, this. So, our trajectory of this, switching trajectory is that one, when C 1 is equal to 0. This is our trajectory, switching trajectory. Now, what about this one? In this case, suppose our point is here, agree. So, our initial point is here. So, what is the value of our state? X 2 is positive, x 2 is positive. So, what is this? X 1 should increase. So, once again it may fall what is called in the, this is the dotted line, and it may be a fall with this dotted line. That means, this is corresponding to the equation 6 and this dotted line equation 7. Suppose it is falls on the equation of that red line. So, x 2 now what is x 2? X 2 is positive, x 1 should increase. Increase means it should go towards this, because minus 1, suppose minus x 1 is minus, then it should go towards direction x 1. So, if it is go towards this one, it is going away from the origin. Suppose it is coming here. Now, suppose this, agree. So, our at this point x 2 is positive. Now, whether it will move along the red parabola or along the green parabola, that is our question now. Suppose it is following like this way in the red parabola, that means u is equal to our plus 1, agree, u is equal to plus 1, and the x value is increasing, agree, it is increasing. So, when it hits here, then u value is your negative, u value is negative, agree. But at this moment u value was positive. When it hits here, the u value is negative. That means, switching occurs here. When C 2 is, this is C 2 is 0. So, our trajectory switching curve will be that one. Now, one may why not it will follow with this green curve? Why not it will follow with the green? Agree? Suppose it is in the green curve, that means x 2 is positive, x 1 must increase, it this one, and it is increasing. So, it will go like this way, and it is going away from the origin. So, it has to go in this direction. So, u is equal to plus 1, and then is switched to e is equal to minus 1. So, our switching curve in this, ultimately it is that is our switching curve. So, this curve is C 1 is equal to 0 from equation 6, and this is C 2 is equal to 0 from equation 7. So, once it is hit here, it will follow along the switching curve, and ultimately it will reach to the origin. So, we can write our control law. You see, now the control law, u star of t is equal to minus sine of lambda 2, and lambda 2 is what? Lambda 2 of 0 minus lambda 1 of 0 into t. So, this again, this is our control law. So, from 6 and 7, when C 1 is equal to C 2 is equal to 0, note that only one parabola from each family passes through the specified terminal point x is equal to 0 and 0 transpose. That means, if you see this one from 6 and 7, if you this initial condition is there anywhere in fourth quadrant, anywhere in the first quadrant, then it will move along the u is equal to first u is equal to minus 1 switch is there, you have to make the switch u is equal to minus 1, then it will go continue along this path. As soon as this hit the switching curve, agree switching curve, that means u is equal to plus 1 is switch, it will follow along this curve and reach to the origin. If it is here again, it will switch to a minus 1 first and then it will switch to a plus 1 control input. Anywhere here it will first switch to u is equal to plus 1 and then switch to u is equal to minus 1, anywhere here. Suppose here you are calling here, suppose here it is just above the switching line, above the, this is if it is here above the switching line. If it is initial point above the switching curve, then it will switch to u is equal to minus 1, then it will switch to u is equal to plus 1. If it is below the switching line, first it will switch to u is equal to 1, then you will switch to u is equal to minus 1. So, this is the optimal time it will require along this trajectory of this one. So, segments of the two parabola, segments of the two parabolas through origin form the switching curve. So, this one segment of two parabolas, two family of parabolas, the segment of this one is this one and another parabola. This is the set of parabolas, family of parabolas, which is passing through the origin and that intersect and that will form the switching curve. So, equation of the switching curve we will discuss later, and we will how to take the decision when that u plus 1 to minus 1 how to take, we will make some logic behind this. We will explain this next class.